Let's look at what is probably the most fundamental and important equation of electricity, Ohm's law. Ohm's law is the basis for the design of all circuits. This is so exciting. In 1827, George Ohm showed that the voltage across a component is equal to the current flowing through it multiplied by the material's resistance. Voltage equals current times resistance. From this equation, we can see that for a fixed voltage supply, a small resistance circuit will result in a high current, and a high resistive current will result in a low current. As an example, let's look at a 5-volt supply connected to a 1 kilo ohm resistor. The current I1 flowing through the resistor is equal to the voltage across the resistor divided by its resistance. The current in this case is 5 volts over 1 kilo ohm equals 5 milliamp. If the 1 kilo ohm resistor is now replaced by a 1 ohm resistor with the same voltage source, then the current I1 is 5 volts divided by 1 ohm equals 5 amps, 1,000 times bigger than the 1 kilo ohm resistor. If you're designing a battery-powered application in which the battery must last years, do you want it to be low resistance or high resistance? Remember that power is equal to voltage times current. For a fixed voltage, if you want to minimize the power consumption, then you want to make the current as small as possible. And how do we make the current small? Yes, by making the resistance as high as possible. Let's look at another example. Suppose that you connect a 1.5 volt battery to a light bulb and a current of 2 milliamp is measured. What is the resistance of the light bulb? We know from Ohm's law that voltage is equal to current times resistance. Solving for the resistance in this circuit, we have that R1 is equal to the voltage V divided by the current I1. 1.5 volts divided by 2 milliamps is 0.75 kilo ohm. So the unknown resistance is 0.75 kilo ohm. Another quick side note here. Our friend, the passive sign convention, also comes into play in Ohm's law. Voltage equals current times resistance if and only if the direction of current flow is in the direction of voltage drop. If the current flows in the direction of voltage rise, then voltage equals negative current times resistance. For example, suppose we have a 1.5 volt battery connected to a resistor 2 ohms. What is the value of the current I1? Note that the current is now flowing in the direction of voltage rise across the resistor, so Ohm's law is given by voltage V equals negative current I times resistance R. Current is then negative voltage divided by resistance, or negative 1.5 volts divided by 2 ohms. The current then is negative 0.75 amps.